there. So if you do look over your exam and you're like, wait a minute, I add up the negatives and I get -5 and you gave me a 52. That's no good. It should be subtract from 100 and you should get whatever score you have. And if there's a problem, let me know. If you think that I graded something incorrectly, let me know. Stick around afterwards. I'm happy to hear you, and I might even agree with you. So, and if you think you deserve a sticker upgrade, oh, by the way, the stickers. So I went through my sticker pile, like my bucket of stickers, and I'm always kind of I don't want to give these out because I kind of think that I don't know who these people are. I guess you have SpongeBob, right? I don't know who the other guy is, the starfish. Who's that? Patrick, is that his name? I think he's gross. I don't like looking at him, and so I've never given these out really, but I thought I'll just get rid of them today. And so I thought you don't have to look at it if you don't want to. If you get a Patrick sticker, I stuck it inside. So anyone with an 80 or above, I stuck one of those inside. Now, if you're jealous of your friends who got Patrick, or if you want to trade your sticker, I have a few left. I was able to get rid of almost the entire school, but so feel free to come and trade. Or if you got less than an 80, but you're like, you know what, I deserve a sticker. I agree. You do deserve a sticker. And so come on up and grab one on the way out if you'd like, or if you want to trade. So that's the sticker story. I buy these things online every now and then, and I don't know. I just thought SpongeBob would be cool, but I didn't realize how big they were. And I didn't realize how grotesque Patrick apparently. He just looks gross. I can't look at him. Okay. Anyway, so that's that. So do tell me, let me know if you have issues with your exam. Stick around afterwards. Let's move on though. Like I said, I was super happy. I'll just set these aside where I can't see them. So today we're going to be working on how to do, I probably have PowerPoint somewhere, but we'll just get right into it. How to set up, no, I need to get the PowerPoint. Give me a sec. Sorry, I should be more prepared than this. It's Monday. That's my problem. I'll just blame it on Monday. Give me a sec here. Let's see. Where is it? Browse. So basically, what we're going to do is we're going to set up the hypothesis test gold for the thing that we're doing, the two mean hypothesis test. So give me a sec here. That's not the right class even. Okay, just a sec. Yeah, so get your hypothesis test gold. Get that spreadsheet on your computers while I goof around up here for just a minute. So give me a minute, and I'll get myself set up, maybe. Let's see. I want to mean. There we go. Okay, good enough. Good enough. This thing. Thought I fixed this. Hold on a sec. There's a mistake I see. I thought I fixed. Let me just check and see if I have it saved somewhere else. I probably do. Just a minute. Two means. Yeah, here it is. Yeah, so this is what, so yeah, now it's all coming back to me. So this is the helium football problem. You remember the two means, you're doing the average distance that regular football gets kicked compared with the average distance of a helium football that was done by the Mythbusters people. And so we're going to do the test, and well, not with the data because I don't have their data, but we're going to do this test on Excel and set this thing up. So the first thing that we need to note is that when we're comparing two means, you're going to be setting this up using the same sort of structure that we've been doing with this looks like a z-score. You have your data, so this would be like the average distance for the helium football and the average distance for the regular football, and you would subtract them, so you're comparing those two, and then you subtract off the null hypothesis. That's what that is. And we'll talk about the null hypothesis in just a minute. And then you're going to divide by what's called the standard error for the mean. And that's what that is right there. So the difficulty is computing all of these things because there's two different formulas. And so the first one is for if, we'll talk about this in a minute, what it means for standard deviations to be assumed to be equal. But if standard deviations are assumed to be equal, you have this nasty formula. It's so ugly. I'll walk you through it. Just be patient with yourself. Be patient with me. We'll get through this together. We'll do it slowly. We'll put that into Excel. Fortunately, the rest of this slide isn't too bad. If degrees of freedom isn't too bad. And then if the population standard deviations are assumed to be unequal, then you use this formula and this degrees of freedom. So that's what we're going to have to type into Excel. This is the main stuff. The rest of it is the same, basically, as what we had last time with our regular hypothesis test for one mean. So let's just talk briefly about what it means for standard deviations to be assumed either unequal or equal. So the idea here is that if you're measuring something, for example, the distance a football goes, then probably the standard deviation will be related to the whole measurement process. And if you're using the same things, the same stuff to make the measurements, then probably your standard deviations will be the same for the two populations. And so if that's the case, that's how spread out. So you can imagine two bell curves, and if they're different means, then they'll be separated from one another. If they're the same mean, then they'll be basically the same bell curve. So that's what typically we're going to use that. But there will be times when you say, I don't know that these two standard deviations are the same, and so we'll use the unequal. I don't really care. I mean, to me, there is such a minor difference in the calculations if we use one versus the other that it doesn't really matter. But because of Newton, we have to do both of them. So we're going to do both of these, and then we'll go to Newton, and you'll see that when it says that you're assuming the standard deviations are equal, you'll use this one, and when it says unequal, you'll use that one. So that's the main difference. So let's get right to it. Let's see. Do I have an example? Yeah. Let's do this example. Hold on a sec. Do I have this on here? I know. Here we go. This for me to see. So this is on our Moodle page. You'll want to download. I should have told you this while I was goofing around. So on our Moodle page, you will find down here in, where are they? Excel files, hypothesis tests. Where is it? Two mean hypothesis tests. And is this today's date? Oh, no, it's not. Close enough, though. That's Saturday. Apparently, that's the day I uploaded this. And I was like, oh, it's today. Anyway, so this is November, it says 16th, but today's the 18th. So that's the file that you want. That's this file over here. So download that, and it'll look like this. And the first problem that we're going to do is the first tab that says grades versus form. So we have the two different forms and the grade. So that's the one that we're going to deal with first. So let's see. So let's go ahead and switch back to PowerPoint while you're downloading. Let me just skip ahead here real quick. Blah, blah, blah. Okay. So this is a sort of question that gets asked whenever I give two versions of the test. And I gave two versions of the test for this test. Now, the data that I have is not your test, but another class's test. But you can see if you look at the top left corner of your exam, you'll see either two triangles that are kind of next to each other left and right, or two triangles that are up and down. So I just picked a couple symbols that look sort of similar to distinguish one from the other. If you have a friend who has the other version of the test from you, and you compare the two, you will find that they are nearly identical. In fact, in this time when I did it, about a third of the test is actually identical. For example, question number 1 is exactly the same on both tests. There are some very slight differences in 2 through 5, and so on. You can sort of look through, you can figure out what the differences are if you care. I think the last page, pretty much the same. I just changed the order. Yeah, I did minor differences. Oh, stickers. Um, so, uh, so anyway, despite the fact that they're nearly identical, and usually when I give two versions of the test, they're nearly identical, I still get this question sometimes. Is one of the versions of the test easier than the other? So we want to be able to investigate this. So what I'm going to do is I'll start off by setting up, I should show you the data that we're working with. Let's see. So the data we're working with is this. I guess I'm going to work with this data. Yeah, we're going to use this data. So I guess it's form P and form T, whatever that means. So you can see these two. Let's see which one is easier, or at least presumably easier. So if you have these data, we're going to need the mean, which is going to be average. Just a minute, I need to be able to see what I'm doing. Here we go. Average of everything in this column. There it is. You can highlight the words. It'll do that. So anyway, it'll just ignore the words if you highlight them. So you'll notice that form P apparently looks like it was easier, at least by the fact that the grades were a little lower. Or no, form P, sorry, that's P was easier than P. Okay, so that's what we're going to be looking at today. Is one of the exam forms easier than the others? So the first thing we do is I'm going to set up the parameters just so I can name these things, because of course if you think, it's like last week, remember with these hypotheses, you're going to name these. Some of you wanted to call this mu sub A. I don't care what you call them whatever you want. Mu sub A, mu sub B, mu sub 1, mu sub 2, just as long as you are careful, you write out what you mean by what you're doing. So that's the first step. We have our hypotheses. This is opposite. Well, it's all right. Should I fix it? Yeah. Easier means higher scores, doesn't it? Yeah, let me just fix this really quick. Why is that like that? You would think that I could keep myself straight. Let me just fix it real quick. It should be greater than, shouldn't it? Greater than. Okay, let's try again. So, yeah. So greater than. Easier means greater than, right? Better scores. Okay, so there's my hypotheses. Notice the hypotheses are for two means, two averages. Next, we're going to do the distribution. The distribution is the t-distribution. I suppose we should name alpha before we get started. Alpha is usually going to be 0.05, but it'll be given to you in whatever problem. So we'll just use alpha is 0.05. And then the next thing we got to do is to come up with the test statistic and the p-value. And we're going to use Excel. So I suppose we need to have this formula. Whoops, there, I kind of gave it away, at least for one of the problems that we have. But let's go get that formula. So we're going to put that formula into here. Wait, not there. I need my hypothesis test gold. There it is. There's hypothesis test gold. And I suppose, give me a sec. I need to move some things around so that it looks good. There we go. Okay, we'll do this and this. Come on, where's my, there it is. Almost there. And there, that's hypothesis test gold, isn't it? Yes. Okay, so I guess I need to advance this. Just a minute, advance. There it is, that's what I need. Okay, so here's our formula. We're going to put that formula into a spreadsheet similar to this. So let's get it set up. First things first, you're going to need to come up with a new tab. As always, if you get stuck, let me know. Don't let me blow ahead, especially at the beginning. If you're like, oh, I just need another minute to fix things. So I'm going to make a new sheet. Oh, it's over there. Let's see. Can I move it? Yeah, move it over here. Okay, so here I'll zoom in so you can see what I'm doing. I've got my new sheet. Here we go. So there it is. I'm gonna rename this new sheet. We're gonna call it two means. Two mean same. Wait, is this same or different? I think it's the same. Standard deviation. There we go. So the two mean thing where you're assuming that they have the same standard deviation. That's what this formula is for. So two means assuming the same standard deviation. So let's hit enter, happy. Let me make this bigger as well. Give me a sec. So is this my mouse? Can I zoom in? I can. Okay, so let's do this. So what we're going to need to do is we need all of this. So you see all of these letters, X bar 1, X bar 2, all of these, N1, S1, we'll go through, don't worry. So X bar 1 is going to be the first thing. Okay, change that to 2. Apparently I can do that. So X bar 2, then you're going to have S1. I don't like the way that looks. How about that? That doesn't look good. There. I like that. You can do it however you want. S2, N1, and N2. Notice that those are all the things that we're going to have from our data that we're going to put into this nasty formula. Let's see, I'm gonna mess around just for a sec, make this hopefully easier to do. Let's see, can I grab this? Yeah, this is gonna be annoying, I know. And almost done. Animation pane. Let me fix this. Get rid of this. Delete that. Okay, there. Now it's up there. And I'm gonna just because I know that this formula is huge, so the more room I have, the better. But I'd like to have that visible so that we can use it and see that I'm just using this. And this is the same as all the other formulas in terms of its basic form. Okay, almost there. Okay, so we've got all that stuff. We also need to have, do we need anything else? I think that may be it for now. Okay, so the next thing I'm going to put is standard error, which is the standard deviation of the sampling distribution. The standard error is this whole nasty thing in the denominator. I thought it would be easier if I put that there all by itself. Ooh, you know what? I just realized, let me put one more thing in here. Let's move that standard error down. We need H sub 0. Null hypothesis. I'll explain in a minute. Okay, standard error. So let's get our data from the stuff that we just did. This is, there it is, this thing. So if you give me a minute, I'll move this over so that we can see everything maybe. Sure. Okay, so I need to have, those are my averages. I need the standard deviations. So SDDEV of all these numbers up here. Oh, I messed up. This is the standard SDDEV.S. This is a sample standard deviation. There we go. So you should have those for your standard deviations. And then the count. Count of the numbers up here. And count only counts numbers. There we go. So there are 15 numbers in that column, 17 in that column. If you can't get these, well, it's not so important that you get these numbers, but it's good practice to make sure you know how to do the formulas. So I'll give you a minute if you want to try to get these numbers on your, these are the data that you downloaded. That's the 2 mean hypothesis tests on the first tab, grades versus form. Okay, no one's yelling at me yet. Yeah, you will soon, don't worry. Okay, now what I'm going to do is I'm going to copy these over. And you know what? I'm going to just copy them by typing because I don't trust Excel to copy properly. So X bar 1 is 92.2. X bar 2 is 90.6471. You can follow along, 4.97422. You'll be doing this for all of your homework. 7.32241. This is 15, and this is 17. Okay, so far so good. We got all our numbers. So yeah, so if you don't want to have to deal with this spreadsheet over here, you could just copy those numbers into yours. But it's super important that this spreadsheet, your hypothesis test gold, is like gold. It's like a brick of gold that you're gonna cherish it and enjoy it as you do your homework. You're gonna be thankful for it. Okay, next, let's deal with our null hypothesis. The null hypothesis refers to, well, the null hypothesis. Let's go find the null hypothesis over here. Wait, where is my null? There it is. There. Null hypothesis. Notice that the null hypothesis is that the two means are the same. It might, I mean, you could say less than or equal to, but whatever. That they're the same equals, which means that there is no difference. The null hypothesis on our spreadsheet is going to be the difference between the two means, the hypothesized difference, which in our case is 0. So there is no difference. In general, it will be 0 for this class. The only reason I'm putting this here is because some of you might, I don't know, take some sort of advanced statistics in psychology or what have you. And this might be useful, might be, might not, I don't know, it's up to you. You save it, it might be useful at some point in the future. So this is just the difference, the hypothesized difference between the means. And for us, it'll always be 0, but in future, you might have a hypothesis test where you say, I'm hypothesizing that the difference is greater than 5. Whatever, you can figure it out. Okay, so standard error, this is where things get ugly. So bear with me. It's that formula that you see up there. The denominator is all I'm doing for now. So this is going to equal the square root. Notice it's a big ugly square root, and I have parentheses for the square root. Then I have an additional, maybe I'll put a space, yeah, just to emphasize. I have another parenthesis, that's for this parenthesis right here. And then I'm going to put another parenthesis. I should have put parentheses around the numerator. So then I have yet another parenthesis, the entire numerator. Now I have n1, which is this number, times s1 squared. So that's this number squared, plus n2 times s2 squared. So you can do this. You could have done this on your own, I'm sure. So this is just the first numerator. That's this right here is this right here. So you've got a set of parentheses for that numerator. Now I'm going to divide, so put a slash, and then another open parenthesis for the denominator, the n1, this number, plus n2, this number, minus 2. Close parenthesis again. Ooh, okay, well, if this is the way it's going to be. Okay, there. Okay, I'm just going to slide this over a little bit further. Okay, we're not done. Here's where we are in this formula. And 3 or 4 of you are going to get done with this, and it's not going to work, and we'll work with you. Okay, so I'm right here with this parenthesis here. So notice, so these, if you can see color, which I don't assume because I have a number of students who are colorblind, but if you can see color, they match up the colors. So this one, the red ones should match up the purple ones, so you can kind of see if you don't have them matched up properly, things won't work. Okay, now we have to multiply by this nasty thing. This, by the way, this is the worst one. If we can get through this, the rest of today is easy. So multiply by, and then open parenthesis for this other one. So that's this open parenthesis. And then I'm going to do 1 over n1 plus 1 over, you don't have to put the spaces. I'm just putting spaces to make it hopefully easier to see what's happening. So 1 over n2, so you can see, so 1 over n1 and 1 over n2. I have the closed parenthesis for this, and then there should be one more closed parenthesis for the square root. So if you match them up, check out the colors. Let me just show you what number you should get, and then I'll show you the formula again. So here's the number. Your target is 2.31. Let me move this over so that, where's my mouse? There it is. Here, move this over, and then I'll show you the formula once again. There's the formula in all of its glory. So take a minute. If yours isn't, if you're not getting 2.31, I can help you. Your neighbor can help you maybe. Someone can help you. We all will get through this together. It's going to be great. I know, there's almost nothing better than having stats at 7:50. Isn't it great? Okay, it's like waking up, you know, like breathing. You get to do some stats. All right, let's move on. Since no one's going bonkers, but if you need to, feel free to go bonkers. It's fine. Okay, next. So now we're going to do the test statistic. So this is the test statistic, T-stat. I'll just call it T-stat for now. And so the test statistic is going to be, let me move this over. There we go. Notice that all I'm going to do is I'm going to do this stuff over the thing that I just did. So I did all the hard stuff. The rest of this is pretty easy. So let me blow through this. And I'm going to have two sets of parentheses. 1, 2. The first one is for the numerator of this fraction. The second one is for that one that you can see up there on the numerator. I have x1 bar minus x2 bar, or x bar 2, whatever, close parenthesis, minus the null hypothesis, which I realize it says 0 here, but really that's the null hypothesis. So humor me and just click that. And then close parenthesis, that's for the numerator, and then divided by the thing that we just did, standard error, and it should be 0.67. So let me just go this again. As you can see, 0.67. I know I keep struggling, but let me know what you want me to pause on. That'll look all right. Close enough. Good enough. All right, no one's going bonkers, so let's do one more. We're almost there. Let me just double check one thing. Okay. Okay, well, I was hoping I could just copy the formulas down from over here, but I don't think I can. So we'll deal with it. This is going to be degrees of freedom. Degrees of freedom is n1 plus n2 minus 1, or 2, sorry, minus 2. So n1 plus n2 minus 2, done. So you have 30. That's an easy one. Oh, what just happened? Why? I don't know why I just did that. How can I get rid of... That's weird. I don't know. I must have pressed something. Okay, apparently I have a little note. Okay, well, whatever. Whatever I did, it was a mistake. So here, let me go back. There. Oh, now I've got the help menu showing up. I keep pressing the wrong key. There, that's what I wanted. Okay, so anyone need help in these numbers? Once you have these numbers, the rest of it is almost, we've done the rest of it before, so it shouldn't be too hard. All right, everyone's like, let's just get through. Okay, let's get through this. Okay, so the rest of the numbers that we need are the p-values. So let's do this p-value. And this is going to be almost the same formula as, you know what, it is so close. I'm just going to go grab my formulas from here. Let me just grab the word to. So copy all of those. I'll show you the formulas, don't worry. So these aren't right yet. Okay, so here is the, let me fix this. So this should be B, the test statistic is in B9, and then the degrees of freedom is in B10. Okay, so that's what it should look like. So left-tailed will be T.test of B9, B10, true. So yeah, and then, here we go. That's that one. Let me get all three of them. So the test statistic is B9. This is going to be B10. So T-dist right of that stuff. And then this two-tailed is going to be B9. I'll show you again. Don't worry. So here's the three numbers that you should have for your p-values. So I'll just show you the top one. If you can get this one, the rest of them we can get really easily. I'll pause for a minute. I know I just copied, pasted, and did this. You might type them all in, but I'll give you a minute to type. just pause for a minute. Let's go down to the next one just to see what it looks like, just in case. So basically, you just have to use for the when you're doing these this is the test statistic. So when it asks for a value of t, you do that, and when it asks for degrees of freedom, you do this number. And then the last one is the most complicated, but it's not terrible. Looks like it's similar to what we did last time, or a week ago. I guess it was last, I don't know when it was. Maybe it's a week and a half ago. So far, so good? Excellent. Look at that. He'll catch up. Don't worry. Evan will be a good support for you. Don't worry. All right. So let's finish this one up. So the last bit is to finish up the hypothesis test, because we've got all our calculation. In fact, I'm going to highlight so that I know not to mess with this stuff. This stuff I'm going to highlight maybe yellow, which is caution. Don't mess with that stuff. Up here, this is the stuff that you'll have to change to match each problem. So maybe you put that like pale green, whatever color you want. I don't care. You don't have to make a color. And I'm going to make a line between the two just to say, look, there's the line of demarcation. You can mess with this stuff above the line. Don't mess with the stuff below the line. So now, if you have a problem on Newton that asks you to compare two means, and it says that you're going to assume that the standard deviations are equal, that's this tab. Type in what you need to up here. You probably are going to leave this h sub 0 as 0. But the rest of this you'll need to change to match whatever problem you are. And then you can use the bottom to interpret. So let's just interpret this just briefly. Remember that the hypothesis test was that the average score for test 3A was greater than the average score for test 3B. And you might think this is weird because it was. However, that was the sample that I took. So this would be the average score for test 3A if everyone took test 3A. And this is the average score for test 3B if everyone took test 3B. That's the idea behind these. And so there are my hypotheses. This is a right-tailed test. Notice that the direction of that thing is right-tailed. Then we go down here and get the right-tailed p-value is 0.25, which is huge. 0.25 is less impressive than a roll of the die. It's 1 in 4. So I am definitely not going to reject the null hypothesis. So I failed to reject the null hypothesis. And you guys, like I said, you were amazing with your sentences in your test. The correct conclusion is that there is not enough evidence to suggest that test 3A was easier than test 3B. We're done. All right, any concerns, questions? All right, we have one more thing to do, and then we're done. So the one more thing is to deal with what happens if we assume that the two, let's see if I've got this here. If we assume that the standard deviations are not equal. So let's go ahead and we'll start by setting up down here. Well, let me see, I gotta be able to see on both screens. There it is. So down here at the bottom of your spreadsheet, if you have successfully made this one, the two means same standard deviation, what you're going to do is you're going to right-click or double-click or whatever it is you Mac people do. Right-click that tab, and then go up here and say Move or Copy. I'm going to copy. I'm going to make a copy of this, and I'm going to put it at the end, and I'm going to create a copy. So make a copy of this because almost all of the formulas will be the same. We will change two of the formulas. So if you have this sheet correct, then just copy it and we'll make the other one. Okay, so let's click OK. Where is my OK button? There it is. So create a copy, and then you should have 4 tabs now. So you have the one mean, you have one proportion, you have 2 means with same standard deviation, and then I have the last one, which is a copy of that, but I'm going to rename that. So give me a sec here, rename. And I'm renaming it two means with different standard deviation. So let's see, different. So I think Newton will use the word unequal standard deviations. We'll take a look if we have time, which we probably will. So two means different standard deviation, meaning that they're unequal. All right, now once you have all of that, press enter. So let's go change the things. We need to change two formulas. So let's see, I need to turn this off. There we go. The two formulas you're going to change are the test statistic, or no, I'm sorry, the standard error and the degrees of freedom. So let's do the standard error first. Let me go back to PowerPoint land and grab the right standard error. It's up here. There, no. There we go. There it is. So it's these two. We're just going to change. So notice this is way simpler, and this is sort of simpler. So those are what we're switching out. Let's see. Can I see everything? I can't. Can I move this? Yeah, close enough. There, that looks good. Okay. So standard error, that's going to be this formula over here. So let's crank this in. Oh, you know what? Just delete this. Delete it completely. Yeah, you get a divide by zero error, whatever. And delete the degrees of freedom as well. Delete. It's gone. Okay, so standard error, the new standard error, notice it's equal to the square root, parentheses, it's going to be way simpler. Square root of the first standard deviation, find that, squared divided by the first sample size, plus the second standard deviation squared divided by the second sample size. Close the parentheses. And that's it. That wasn't too bad. And then the degrees of freedom. Degrees of freedom, notice it's the minimum of the two. So in this case, it'll be 15 minus 1. But you can type this in so that it works in the future for all of your problems, equal to the minimum of, you can highlight comma and highlight that, minus 1. So notice it's the minimum of both of them, and then subtract 1 outside the parentheses. Hit enter. There it is. Done. We're done. Okay, we're done for the day. Well, not quite. Let's go take a look at another example just to make sure that we can do this, and then we'll take a look at Knewton. So here's what I'd like you to do is go to this spreadsheet that we have. Whoa, just a minute, that's not right. I need to be over here. Okay, so get this spreadsheet. Just a minute. Let me make this like this and this. There, that's better. Okay, so these are the data over here that we had. And so here's what I'd like to compare. Let's go to Taylor Swift. So Taylor Swift is in the spring. I asked my classes, just like I asked this class, what year did Taylor Swift's 1989 album, when was it released? And so I thought that the males would be different from the females. That was my hypothesis, is that males were different from females. I wasn't sure if the males would be more or less, so that's why I'm saying different. So my hypotheses, I don't have my iPads set up, but I guess I could write it over here, here we go, my claim is that the male mean is different from female mean, and you can't see it. Here, I'll just fix that. Just a sec. You gotta be able to see what I'm doing. Where is my stuff here? Okay, I give up. I'll just just make it a little bit smaller. Move it over. Come on. Okay. Well, yeah, the male mean is different from the female mean, and then we have the null hypothesis is that the male mean is not equal to, or no, equal female mean Yeah, this is getting really ugly. And then the alternative hypothesis is that the mean sub m, the male mean, is not equal to the mean. Okay. I could go and find all the, I could put the actual symbols in here, but I don't want to bother right now. So you get the picture. I've got my hypotheses. So let's actually do this. So you have the data. The data are right here. Where are they? Where is it? Oh, it's right here actually. It's over there. Yeah, so you've got the data. Go ahead, take a few minutes, and we're going to assume that for whatever reason that the standard deviations or the variances are unequal. So assume that they're unequal. See if you can come up with the conclusion for these data. So you'll have to find the mean, standard deviation, and the number of each of those columns. It won't take too much effort though. Meanwhile, I'll just take a minute to find my Newton to make sure that that's all set up for you. Okay, good. Hmm. All right, well, here it is. Okay, I'll put this back up. Yes, sir. Let's come around. Is it? Which one? Different? Let me see what you have. Oh, you have nothing. Well, okay. You just watch the video later. No, just kidding. Here, let me get it. Let's see, which one is it? It's this one. Is this the one that you're looking for? Yeah, it's a easy, fortunately, relatively easy. There it is. Oh, sorry. Oh, sorry. What in the world? I thought I could. I can't multitask. Yeah, if you need any other formulas, I'm happy to click and show and make you happy. Okay. You got that? Yeah, let me know when you got it, AJ, and then I'll switch over to this other sheet. Statistics. Okay. All right. Let's see how you did. Maybe I don't know. We'll find out. Okay. So over here, what I'm going to do is I'm going to first of all compute the means and standard deviations. So equals average. Oh, you know what? Let me show you a little trick here. So I've been hesitant to use this trick, but I'll do it now. We have mean and standard deviation and number. Okay, here we go. So Mean is equal to the average of column A. So you could do the average of the entire column A. The reason I've been hesitant is because if there's anything other than your data in column A, that will give you the wrong answer. But I know that the only thing in column A is my data, so there's the average of column A. And then I'm going to have equal to the standard deviation dot S of column A. So A colon A means everything in column A, ignore the words. So that's that. So it's just a quick, easy way if you're really careful. And then this is the count of column A. Oh, whoops. I forgot my equal sign. Stick an equal sign in there. And so you can see this is super easy. If I do it this way, I can copy all of this junk over, and there's column B. So each of those are column B. For example, this one is the average of column B, but you should have gotten these numbers. Now that we've got the numbers, I can just copy them over to the other spreadsheet. So let's see if I can find myself. Here I am. So notice X bar 1, we're gonna, wait, where is it? We have to be super clear about who's first and who's second. So this will be X bar 1. So what was that? Is that the males or the females? Females, ooh. So it's really important to keep this straight. So I guess I'm doing, yeah. Well, I've got males first in my hypotheses. Okay, so I'm going to switch it up. I'm going to use males. No. Here's what I'll do. I will change my hypotheses so that the females are first. So give me a sec here. Just so that I can be consistent. And the reason this is important is because all of the calculations are dependent upon which of these is first and which of them is second. So if you do the calculations with the females first and the males second, you'll get different numbers than if the males are first and the females are second. So there are my numbers. Let's see there. So the top number is the female mean, and then the female standard deviation, and so on. So this will be the female mean, 2011.33. The female standard deviation, 5.54514. Oh, no. Just a minute. That should be here, shouldn't it? This will be the male mean, 2006.49. Okay, the male standard deviation is 9.17907. And then the numbers, we have 43 females and 47 males. And then the null hypothesis will stay the same because it's just the way it is. Okay, so I suppose I should have decided on an alpha level ahead of time. I didn't, so we'll use 5%. So notice that we have all of the information that we need. I have a two-tailed p-value because this is a two-tailed test. And so because the two-tailed p-value is 0.003, less than alpha, I'm going to reject the null hypothesis, and my conclusion will be that there is evidence to suggest that the female average Taylor Swift album year is not equal to the male average for Taylor Swift's album year. I guess that's terrible English. Let me see. The average that females think that Taylor Swift's 1989 album was released is different from the average year that males think. That's what I would say. But anyway, enough of that. Yeah, you did a great job on your test. I'm just telling you, I had a smile on my face, and my wife was happy too. Okay, so that's it. That's it for today. We're done. Okay, here, let's take a look, though, at the homework. So here's a preview of the homework. You have 2 sections. I'm a little bit concerned because one of the sections, why is this not getting bigger here? Now it's getting bigger. One of the sections is sort of similar to one that I had it do last Friday. Let me just tell you about last Friday. The one that I had to do, remember, I canceled it because it wasn't working. Anyway, I actually went and I complained to Knewton, and they said they fixed it. I don't know if they really did. But what I need from you, though, I don't know. How about this? Here, let's see how things go. Okay, so there's two sections. One of them is the perform and interpret a two-mean hypothesis test with Excel, and that's this one. And so the main thing to look for, let me see if I can find it. Let's see. Oh, come on. Standard deviation. Where is it? There's going to be a statement about, I should have found it earlier. Blah, blah, blah. It doesn't say. Oh, just a minute. Maybe it'll say in a bit, so I'll just cheat. Okay, you can do this is easy. You can do this. Give me a sec. Here's the actual data. Oh, we need to have, using Excel, test statistic. Where is the thing? There should be, oh, here it is. I didn't see it earlier. There's the statement. You see that statement right there? So somewhere within the body of your problem, it will say, assume that the population variances are not equal, or it will say, assume that the variances are equal. So if it says not equal, you'll use the spreadsheet we did for not equal, standard deviations. Standard deviation and variance are related. And if it says equal, then you'll use the first one we made. So that's the main thing there. So I think you can deal with the rest of that. Now let's just take a peek at the other one. So the other one, so that's one of the objectives. The other objective, this might be a problem. I'm a little leery about this, but we're going to try it. It's basically doing the entire hypothesis test. They give you all the stuff. So how are we going to do that? Here, let me just, yeah, let's do this one. Let's just see if this works. If it doesn't work, this won't take long. So I know you're all packing up and leaving, but bear with me for just a minute. So here is this. Notice that they give you all this information. Let me just say, blah, 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 longer. Okay, company A is longer than company B. And so the hypotheses, okay, I'm going to have to deal with this. Here, I'll just cheat. All right, I don't want to have to do the instructor cheat, get it all filled in. Then I don't have to deal with the, there we go. So you'll have to deal with that. I'm sorry. But anyway, the thing I wanted to check was, will this agree with what our spreadsheet does? And you remember that the one that it was for Friday didn't agree, and so I complained. So let's see, where does it say standard deviations, normally distributed? It doesn't say whether we should assume the standard deviations are equal or not. Does it say below? Provide null and alternative. Wow, it doesn't say. Wait, why doesn't it say? Normally distributed. Huh. Maybe I have to delete this. Just a minute. Let me just see what happens here. X bar 1. Just copy this over. It'll just take a sec. So yeah, let's see what happens. X bar 1, X bar 2. You can see that it's already, whoops, 4.5. All right there. S1, S2, 0.8. And then we got 15 and 20. Okay, so my test statistic is 1.39. Let's see what they have. 1.398. Okay. Huh. And this is the different, the unequal standard deviations. Huh. So I guess that we're just going to use the unequal. That's sort of my go-to thing, is if it doesn't say, then I always use unequal, because, you know, we'll just assume that they're unequal if we don't know. So I guess that's what we should do. And it looks like it's getting the same answer as I did, so hopefully they have their code written correctly, because that's exactly the same as what I have. So try this one. If you get frustrated, then just send me a quick email. You might even make an appointment, but send me a quick email first and say, it's not working. And I'll take a look, another look. But I'm hoping this one is correct. So we'll find out. All right, thanks for sticking around. If you want to talk afterwards, please do stay and we'll chat about your test. And I'm happy to do that. Stopping the recording.